Hi, this is Pat Moorhead, and we are back for another episode of the Moor Insights Strategy Data Center Podcast. It is Friday, and it's episode 13, but please don't let that freak you out. I'm not 100% sure something weird and creepy isn't going to happen, but it might. So I would stay tuned and watch here. So, Paul, how you doing? Matt, how are you?
Doing great. How about you?
I'm doing awesome.
Yeah, been a little travel. Paul, saw you at the IBM event.
Yes.
We went nuts on doing research. Matt, it was nice to see you this week. It's so funny. Somebody asked me, "Hey, did you travel this week?" I'm like, "No, I've been home all week." And then I looked at my calendar. I said, "No, I've actually have been traveling." So I think it just shows kind of what happens when you do all this traveling. Looking forward to the F1 weekend here. I did get an invite to go, had to turn it down because I just traveled too much. But I am here in spirit, wearing some merch from Lenovo. So anyways, thank you, Lenovo. And by the way, if you give me good merch, I will wear your merch too. Probably won't use a backpack because I have 300 of them.
Right.
And give them away to organizations and schools that need them. But hey, we have a full freaking show here. I mean, I think this is the most topics we've ever had on here with one less person. Will is probably at happy hour in Japan right now doing something fun.
Right.
But a man who probably travels more than any of us. But we're talking Microsoft jumping into the data center silicon game. We're going to talk a little bit about Supercomputing 23, little Dell Technologies Analyst Summit recap, talking about quantum utility, and a whole lot more, including AWS. So why don't we jump in here, Matt? You and I kick this. You kick this off, and I'll play sidekick on that. But Microsoft very much jumped into the custom data center silicon game.
The joke there between Pat and I for everybody is he rightly points out that I only think about data center and servers when I talk about silicon and everything.
Which, by the way, is good because guess what? Because that's what you do, right?
That's what I do. It's fun stuff
but
too.
I find myself going in and editing research or blogs, adding that data center edge, data center. But
I know.
Good stuff. So what did they do here?
It's crazy. It's crazy. By the way, just before we start, the whole creepy vibe thing with Paul and I on here, it's bound to get weird and creepy at some point. So I just want to throw that on there. So two things, right? First, Maya, obviously custom Microsoft built ASIC for AI, and Cobalt, an ARM-based CPU. So getting into both of these, everybody knows Azure is obviously a huge cloud provider, has invested a lot in but enabling AI for enterprises. The work they've done hosting OpenAI and a lot of other work it's absolutely incredible. So, they while they partner with all of the major players, lo and behold, they announced at Ignite, first day of Ignite, that they've created or they've designed and built this ASIC, this AI ASIC known as Maya. What do we know about it? So they didn't give any performance numbers. What we know is that it's built on open standards. There's a body within Open Compute that virtually every player is part of: NVIDIA, AMD, Intel, Qualcomm, Meta, around how you design your hardware to better support the AI frameworks that are out there. And Maya was built to those specs. That's a good thing. So embracing openness, which we all love. We also know that you can fit 4 of these onto a server motherboard. And while we haven't seen performance numbers, it's clear that this is, they're positioning this as that enabler, just like the H100 is, just like the MI300 is, of Gen AI and other AI workloads. We forget there are other AI workloads out there. What I found really, really interesting about this, 2 things. The first is that they, as Microsoft did this, they actually kind of went down this path of when you think about sustainability and how you power these things and cool them, they actually built their own liquid cooling method or product to go along with it called Sidekicks, which I thought was really fascinating. That's the first part. The second part is, they took this approach with Maya that I absolutely embrace, which is, if you're really going to provide the best absolute performance for your AI stacks to the marketplace, you got to customize it from the ground up, right? You've got to have that fully enabled platform from silicon all the way up through the stack to provide what you can do for best performance and performance per dollar. And that's how they measured their development of Maya. So I think it's a great move. They still partner with NVIDIA. They still partner with AMD. I'm sure they'll partner with Intel at some point. But clearly, they have big plans for that. For Maya. Part two, Cobalt. Crazy, right? 128 core part based on Neoverse V2. They built it on ARM CSS, which is a big deal because it allowed them to get this product out very quickly. They position this as supporting their 1P platforms. So in press releases, they've mentioned that they're supporting Teams and Azure SQL and other 1P workloads. This is interesting for a couple of reasons. One, this was a part that ARM was a strategy that they first embraced a long time ago. Worked with Ampere to deliver the older Ampere part in production, I guess in 2022, mid 2022, and they've also embraced AMD one socket part to power their one socket VM, their kind of scale up VMs as well. So I'm kind of curious, not just from an Ampere perspective, but from a overall perspective, how much Cobalt eats into the suppliers that have been supporting these Azure general compute instances for a long time. So I talked for a long time. Sorry, Pat, I know you get a lot of thoughts on it.
No, listen, we could spend an hour on this thing. I mean, I have publicly viewed Microsoft's lack of compute and AI custom silicon as a potential liability moving forward, either on supply chain resilience or on cost. And when you get to a certain amount of scale, and if you look at the amount of IP you can pull off the shelf, the quality of the tools and the IP that has been certified all the way down to the foundry, you aren't spending $1.5 billion on a custom piece of silicon like I did in the old days. And this was a good first step, and I was very surprised that it all came out. And my vernacular was, it was all shock and awe, right? Yeah. Like, I mean, hitting literally all at once. One thing I was struck by, and I'm wondering how the industry got stealth, is they literally said, we designed the IP, the custom IP that they had. They leveraged third-party IP like Neoverse N2, but they taped it out. So all the way from design to tape out to validation and taking it to the fab, and there was maybe one leak, right on the information, and I am just dumbfounded. And what happened, and what I've seen, is that people didn't move their LinkedIn's over. And they didn't move their Twitter or X handles over, because one guy got up and said, "Hey, I could finally talk about what I've been working on for 3 years." It doesn't even say Microsoft.
Yeah,
it was his prior company. So big job stealthing that. I did see some of the performance data that did not go public, and it was very positive. What I do want to see is the new custom silicon compared against AMD, Intel, AWS, and Google Cloud. And by the way, I don't think it has to trounce it. I think even if it's close, it's competitive, and if they manage their costs, they're not paying an arm and a leg. I also want to see pricing for the custom parts, and pricing for the AMD MI300X, which, by the way, kudos to AMD. They got their first CSP to embrace it. I also want to know when the dates are going to be for full IaaS, meaning anything on Azure. Like Graviton today, any customer in AWS can light those up, right? That is not the case with Azure yet. Also would like to see the day that they support M365, Dynamics 365, and I'd like the official GA dates. I like the way they're rolling it out, which is primarily to support their SaaS services. That this is what happened. This is what Google did with the TPU. The first 3 versions were really internal only. Google Search, Google Photos, stuff like that. I don't think it's going to take 3 years. In fact, this Maya supports the Open Azure AI Service, which is fundamentally the ability to light up stuff there.
Yeah.
So, congratulations to Microsoft. I think it's a really solid start, and I definitely am looking at their capabilities in a different way today.
Yeah.
So let's move to the next topic. I think we're 11 minutes in here, and we're into topic 2. AI equals 1 trillion watt hours. Paul, you always know how to bring the mystery when I really have no idea what you're going to talk about, but what are you talking about here?
Well, I was doing some research. I ran across a kind of a neat little paper. It was written by a PhD candidate at the Amsterdam School of Business. And he wrote it about AI energy consumption trends. I mean, it's no secret to anybody that AI sucks up energy like a sponge in water.
AI does suck. It does.
Yeah. He did have some really kind of interesting facts in here, and I thought I'd talk about them today. He said that the estimates for power needed for an AI query runs about from 3 to about 9 watt hours, compared to 0.3 watt hour search for just a regular standard search. So that's, to me, that seems like a lot of money to spend for provide a search query. I don't know about you guys, but it does do a lot better job. I mean, if you don't get things that are hallucinating, you get more of a comprehensive report. But I've kind of gone back to regular Google searches and information like that, because it seems just a little bit more simpler, and I believe it's a little bit more trustworthy too. Points out that the AI chip demand is surging, but the supply chain issues is going to kind of constrain the growth in that area, and I think that's kind of just obvious. So, he had a statistic in there that he said if Google goes to full AI adoption on everything, it would increase its electricity use by about 30 trillion watt hours a year, which seems really expensive to me. I don't think they're going to go full AI on everything, but that's a significant figure. And I mean, we're already an issue. We're kind of worried about how we're going to supply power for all the AI that we're going to be using. So it's a good fact to keep in mind. He said that in the study, he said that the long-term projections for like 2027 is going to be from 85 to like 150 trillion watt hours annually for AI servers. So that's definitely going to put a squeeze on our power.
Hey, Paul, can I ask a clarifying question on this?
Sure.
Is this so, in my simple pea little brain here, you can do AI 3 different ways. You can do it analytics based, you can do machine learning, deep learning, and then about 10 different ways of foundational models. If you want to do text, it's LLMs. Is this an LLM power?
Yeah, he's looking at LLMs. Yeah, that's right. Yeah.
Okay.
I think that's where most of the power consumption is going to be. I mean, it takes a little bit for machine learning, but the LLMs and
rule of thumb, what I've seen and when I've talked to CSPs and people doing applications is, again, it all depends, but there's a 10x training increase and shockingly a 10x inference increase as well. And part of that is because we're doing this on GPUs.
Yeah.
And although GPUs would be better at it in big batches than CPUs, and you do have some ASICs that are sitting on a GPU like the Tensor cores or ASICs, we still have all of these ASICs that can do this at about 10% of the wattage. It's just harder to program. And that's why people are jumping on AMD as the number 2 here, because it's GPU based, and customers are preferring ultimate programmability to not miss the boat with GPUs versus going headstrong. And Intel's Habana 2 architecture is more like an ASIC as well. But it definitely highlights the challenge that we have going forward. The topic that we talked about with Maya is interesting because it is an ASIC, and it adds programmability at the API and at the I don't want to call it the firmware level, but up there with things like PyTorch and also the framework level.
Mm-hmm. It's interesting, that you guys talk about this. If there are statistics out there from the International Energy Association. So data centers today consume, I think it's 1.3% of the world's power, right? That's the equivalent of the country continent of Australia. And they're saying by 2030, it's going to be 3%, but they haven't yet accounted for the AI wave. It's crazy how much more power AI is going to add to that equation. And it's not just how do you supply the power. I'm a big believer, not sustainability, but kind of cooling methodologies. It screams to you got to figure out a different way to power and cool these platforms that are doing your training and inferencing for you. You can't just go with a bunch of fans or the traditional data center cooling methodologies. HVAC's not going to do it anymore. But
yeah, by the way, I said framework, I meant compiler, right? And that's how Intel is doing it with Habana 2. So hey, let's move to the next topic. Good job, Paul. Oracle hosts PostgreSQL. Wait a second. The company that is MySQL, what are they? What's happening here?
Isn't this crazy? I feel like we have every podcast we have, Oracle is mentioned, but they're that kind of disruptive. I love it. It's like the kid you can't control. So yeah, Oracle is hosting PostgreSQL as part of Oracle database in OCI. So it's a database service. PostgreSQL, the number 4 distribution in the world, the number 1 enterprise open source database distribution. MySQL is as well, but there are limitations to MySQL. PostgreSQL for many years has been a serious competitor and threat to both Oracle and Microsoft SQL Server and Oracle Database. And lo and behold, Oracle Cloud comes out with an announcement that they're going to be hosting PostgreSQL up in the cloud. It's not in any way. They haven't. They've taken the open source distribution and created their own for service. They haven't limited the functionality in any way to disadvantage it versus their Oracle offerings in any way whatsoever. It's part of their embrace of the open source community. They've done it with OpenSearch and a number of other functionalities as well. Really not a long discussion on this. It's just I wanted to throw out there I love to see how aggressively Oracle is going after the cloud and establishing itself kind of as the data cloud, if you will. And they're doing it understanding that, kind of this is a different market they live in. And it's no longer just about selling Oracle database licenses. It's really, this is openness at its finest. And this is the last company I would have thought 10 years ago would be supporting PostgreSQL. So
yeah, I think this demonstrates to me that they want to be a larger open platform IaaS play, right? Mm-hmm. and maybe even a PaaS play if they're going to do Postgres as a service. And you have to do that when to grow that IaaS footprint. Now, just to be clear, you said in the cloud this is an OCI service, right?
Correct. Yes.
I got you.
Yes. Yep.
Can you run this on-prem as part of Cloud at Customer by chance, which is
It's
quote
part of
unquote on-prem cloud?
Yeah, as it's so if it's part of the OCI service, you should be able to run it. Yeah, as Oracle Cloud at Customer, you should be able to run it on-prem as well. Yeah, yeah.
Okay.
It's really brilliant if you think about it. I mean, just like MySQL, organizations are huge. There is no single standard for databases within an enterprise. Even though you might set that standard, open source databases are getting used everywhere. And Postgres is everywhere. To embrace it rather than push it away, it's a brilliant move. I mean, it's certainly going to. Anyway, I'll show you. Get where I'm going.
I get where you're going, buddy. I got it. I
can ramble on. Sorry.
Yeah. So let's shift topics to the quantum world. Quantum utility, Paul. I feel like I've heard this term before, and we used to use this. Yeah. Well, what's happening? Is somebody redefining the definition?
No one's redefining it. We're just kind of re-emphasizing the fact that there is utility in quantum computers like around 100 qubits. They're able to solve problems now that are beyond the old brute force classical simulation of quantum computing, and there's some useful tools for looking at some scientific problems. There's a number of things that IBM did and published in Nature. It shows that there really is utility in quantum right now instead of just doing the research on it. It's not the same as quantum advantage. That's like speed up over the best classical method. It's actually just using quantum for coming up with solutions that point to the right answers. They're reliable solutions, and it's an alternative to trying to craft a classical approximation for a similar product. So you'll get a better answer, and I think it's a significant practical benefit overall, all the classical methods. So anyway, we should start looking at that, and pretty soon we're going to be at a point where we can actually use quantum to do some serious work. And IBM is doing a lot of experiments with over 100 qubits, and they've got a program for that. And there's more and more things appearing on archive of people using quantum and coming up with some useful information. So,
yeah, I interviewed Jay Gambetta in Spain when they released a paper showing it wasn't quantum fault tolerance, but it showed a way to improve the quality of the qubits in the flow without having them lose their power. And there was a lot of discussion about quantum utility on that. I think what did confuse folks is that Google said hey, we've got quantum supremacy. I think two or 3 years ago. So
yeah. IBM is doing some experimentation with a fault-tolerant code called low parity density error check, and it's got some. It looks pretty promising, and they mentioned that they've been working on that for a couple of years. So I think that's probably what he's talking about.
Looking forward to it, and I can't wait to be able to talk about all the secret stuff you and I learned at the Yorktown Research Facility that I think is going to blow people away. But I don't know. Let's just spill it on this podcast, Paul, and break all of our NDAs.
Put up that slide.
Yeah, they wouldn't mind, would they? I don't know. Okay, let's not. Hey, let's jump into Moor Science, which is Supercomputing 2023. Matt, you and I partied there. Almost got squished by 10,000 people. up the line. I literally felt like I was at the Consumer Electronics Show. The only difference was the IQ is probably 50 points higher on everybody there,
Yes.
not including me, of course, and nobody was drunk. So
That's true too. That is so true. That is so true. It shows you, yeah, just how smart they are. Yeah, I have to say, supercomputing might be my favorite show. Um,
what?
I know it is a nerd's like dream come true, right? I mean, it
Yeah.
truly is. It's because it's the best of everything, and it's kind of science fiction come to life in many ways. I absolutely love it. And here, so kind of that bleeds right into first takeaway is I couldn't believe. I'm always shocked every year at how crowded supercomputing is and how popular it is.
Yeah.
You go to these vendor shows and they have, 20,000 customers, 15,000 customers, whatever it is. And they're all customers, but they're all there kind of, it's more business as usual. Supercomputing, it is just kind of an organic growth of academia, research, and commercial nerds coming together to share best practices. Absolutely. So I love it. But three big takeaways. I'll give you four. First is silicon is more vibrant than ever, without a doubt. When we think of silicon, again, kind of my brain goes to servers, and it's AMD, Intel, ARM, NVIDIA. Throw Qualcomm in there as well, but you forget how vibrant silicon is. And Maya and Cobalt are just an example of that happened out of Ignite, but just example of like how innovative the silicon space is becoming and how quick the rate of innovation has become as well. Remember, you used to see chips come out every 3 years, 4 years or so. I mean, there was a reason for it, but there is just a consistent drumbeat of new silicon startups coming out every month, it seems, and they all collect at supercomputing to talk about their latest innovations. Part one. Part two, in the era of open source, which is what HPC, supercomputing, AI is all about, maybe not AI, but HPC and supercomputing is all about, the big guys have never been more represented. I was shocked at the presence that HPE, Lenovo, Dell, Intel, AMD, so on and so forth, and Microsoft had at Supercomputing 2023. And I know they always have a good presence, but their presence was huge. And it shows that, while we think of these players as kind of like standard server or maybe as a service providers, there is a lot of innovation going on in these companies as well. And IBM, I'll throw in there as well. Number three, is supercomputing all about storage? I could not believe the size of Vast's and Pure Storage's booth at Supercomputing 23.
Yeah.
And those stupid cowboy hats. I admire.
By the way, Daniel Newman took one with him and walked out, and he went to the airport, and everybody was looking at him really funny, like, are you possibly a dancer from Las Vegas with that hat?
Oh, that's funny.
But the question is, did you go home with one?
I did not. I wouldn't even put one of those on. I don't have a head for hats.
I just see ugly and I walk away. So
yeah.
Now, just in full transparency, he brought one back to one of his kids, and I thought that was really sweet. So
yeah, that is very cool. But they were huge, and Vast had a huge presence. Pure had a huge presence. Weka, lot of storage companies there, and it really kind of reminds us that how critical storage, but really data, is to the kind of the supercomputing equation, right? We all know that, but we forget that these storage companies aren't just providing disks that you can store data on. They're doing a lot around data management. Last thing I want to hit on is cooling, and I hit on it, kind of touched on it a second ago, but I could not believe the number of cooling companies that were at supercomputing. And it really speaks to the recognition that enterprise organizations are kind of starting to realize around the growth that's going on in the data center. The TDPs of these CPUs, GPUs, ASICs, and other pieces of silicon that are populating the data center more and more, and the need to figure out a way to lower your power consumption. I mean, when you look at data center cooling, it's 40% of the power budget, right? You got to figure out a way to do things smarter and take up less of a footprint. So those are my 4 really big takeaways. And again, I know I'm going through fast because I tend to ramble on, but man, I love that show. And Pat, I know you have a lot of thoughts about supercomputing as well, so I didn't want to steal your thunder.
Yeah, it's a good show. I hadn't been there 5 or 6 years pre-P. I don't use the word so it didn't get flagged. But no, it was pretty big. Marketing dollars are tight overall, and not a whole lot of people make a whole lot of money in supercomputing. It's kind of the thing to lose money on, particularly at the big national labs. And what you do is you get them to pay for your intellectual property and our engineers, so you can take that IP and use it other places where you can make money. So it's kind of a freemium type of model. No, first thing is we're seeing a movement from flops to tops. Okay.
Yeah.
And for decades, it was all about floating point operations per second, right? Yeah. How do you do simulations, weather simulations, crash simulations, not nuclear simulations? No. We're just doing weather simulations at the Department of Energy. And no, it's code. I've got some funny AMD stories that if they didn't cut off my internet, I might tell. But anyways, flops to tops. If we've seen in technology, rarely do technologies die. They just decline, right? I mean, I think we can safely say the fax machine is pretty much dead in most parts of the world, but it's typically additive, right? Machine learning didn't kill analytics, deep learning didn't kill machine learning, and generative AI is not going to kill the deep learning. Okay, it's additive. So, and that's what's going on here. But what I did here, and I actually interviewed with the Imperial College, Flatiron Institute, and the folks at LRZ, and every one of their research directors told me, all in on AI. Okay, all in AI. It's giving us new ways to figure out the problems. And people inside of the universities and my users, they want to be able to do that. And it's not the first time we've seen AI being introduced. What was happening is they were using AI to narrow in the problem set, and then they would throw flops against it. Now they're looking at this amazing multivariate, multi-parameter foundational model approach to do real wackadoodle things in between now and when quantum computing pretty much reinvents that entire place. No, I saw
they're using AI for quantum now too. So
exactly, and that's what's great about all this technology and more innovation a lot quicker. A lot of CEOs were there too of these companies that don't necessarily stand for classic high performance computing. I met with Jonathan Ross, the CEO of Grok. They have an ASIC based solution that runs, Lambda 30 billion parameter model about 10x faster and more efficient. It's an ASIC. Guess what? And I think, by the way, it's fabbed in 16 nanometer or maybe 12. Yeah. Again, just reinforcing that. Met with the CEO of a company called Axiato that essentially has a plug-in card that replaces BCM, root of trust, and a lot of the popcorn that enables multi CPU and multi GPU brands who have been plopping this stuff either inside of the SoC. So I was really impressed with this. So yeah, those were some of my key takeaways. I think I was there for 24 hours. Showed up, you and I, to toast HP's Aurora being the number 2 fastest, while, by the way, uncertified and using half the capacity.
That's right.
I think that's the takeaway. I want to make sure we we get that right. Spent a lot of time with Lenovo. Lenovo's still the market share leader in high performance computing, and they do 50%. They have 50% market share just in Western Europe, which is pretty incredible.
Yeah.
Yeah.
Hey, one last. Can I throw one last thing in there? I was
Yes, you can. It's your show, dude. It's your show, not mine.
I was surprised to see, and I'm kind of curious to get your thoughts on this. So there were three cloud providers there, GPU cloud providers there: Lambda Labs, CoreWeave, and Vultr. And there's an AI thing. Yeah, I know. It's a ghost over my shoulder. And I'm kind of curious as to what your thoughts are around kind of these AI cloud, if you will, or GPU cloud players, and the impact they have on the likes of AWS, Azure. Not really impact, but I guess the cloud market in general. Do you see this opportunity for bespoke clouds, so to speak?
I see this opportunity as like a really teeny tiny one, and they need to get in there and strike while the iron's hot. So CSPs didn't use water and to cool, and these new breed of folks do. One of these, CoreWeave, is partially owned or invested in by NVIDIA, which means that they can get GPU. I think there's going to be an opportunity for these folks if they're not just propping up services for NVIDIA cards, right? And they can provide some heterogeneity out there and some choice. Because when it comes to the AWSs, the Azures, and even the OCIs and Google Clouds, they need scale, right? They need to put this in. They need to stand up a new piece of silicon in 27 different data centers, right? Whereas opposed these smaller ones, who, by the way, are typically in a colo and an Equinix or Digital Realty, where they don't have as much of the pressures. So I'd like to see, Habana 2. I'd like to see Grok in there as an example.
Yeah.
Hey, let's move. What do you think? Are these flash in the pan based on the inability to get GPUs, or something different?
No, and I don't mean to belabor it. I'm with you. I think, I see it as an opportunity, like you, kind of the smaller, more agile, an opportunity to strike while the iron's hot, certainly. And I see with some of them more than just renting out GPUs. Actually, all of them have some additive service on top of the platforms. And I do think that not owning my own real estate and having to worry about owning my own real estate gives them a little bit of agility. But you land and you got to expand, and where do you expand to, right? That's the part that I get stuck on. But
all right, let's move forward here.
Yeah.
This looks like a topic for Paul, because again, it's something I've got no idea what it is. Okay, maybe I'm lying. I've seen the link. I know where this is going. So Paul, are we giving $2 million pay packages to generative AI programmers?
Well, I mean, what would you do if you got the top product in the market and you've got you need resources? What would you do? You go poach on your competitors, right?
Probably. Yep.
So AI has been poaching employees from Google, and they've been offering some pretty neat little packages for them. I mean, you just take a guess what type of compensation package they're offering to these senior researchers. Just take a guess, Pat. Annually.
Well, listen, I've got a pretty good. I didn't read the article yet, but it was $1 million at NVIDIA with machine learning. I'm guessing 2.
What about you, Matt? Take a guess.
I'm going to do my Austin Powers. $1 billion.
Okay, it says that they've been offering annual compensation packages worth $5 to $10 million, mostly in
Wow.
stock. I mean, if you got all that stock, you can give it away, but that's a nice package. So these guys are probably trading $1 million packages for $5 million packages. So it's just kind of a sign of the times that AI is stirring up everything, including taking away from the bottom line with all these outrageous stock packages. But I guess if it's stock, then it's probably okay. So I mean, it's just a big battle. So Microsoft's got to be involved in it, and Google. So I'm going to be an AI programmer. So
Why not, Paul? I mean, my son Pico is absolutely headed in that direction, and I'm waiting that he can get in so I get some early retirement.
yeah,
So
yeah,
have him live in the condo and charge him just way more than I should for his room, something like that. No, listen, it's a feeding frenzy right now, and none of this is new, right? We saw the feeding frenzy with COBOL programmers early on with IBM. When they went from machine language to COBOL, we saw this with SAP. Was the big, crazy, hey, if you're an SAP programmer, you're going to start at 250 grand a year, right?
Yeah.
And then we saw it with machine learning with NVIDIA offering $1 million in cash plus stock. So yeah, I mean, if I could turn the clock back and do something like that. The one interesting thing though is, do they really need to be PhDs or not, right? That's even Apple, right? Just to give you guys an idea, like yesterday I saw a leader from Apple, ex Google DeepMind, trying to recruit people on Twitter, right? But the line was PhD, right? And I don't know, Paul, is that fair? Is that not fair from what we know?
hey, fair is fair.
Yeah.
So
No, I got you. Hey, let's move to the next. We got 6 minutes to get through this. Dell Tech Analyst Summit. Do you want to do the? I have the privilege of going first here, Matt.
Yeah, sure. I'll go fast too. So fast to me means I'll only take 10 minutes.
Good. I'll
Just
cut you
for
off.
just kidding. Three big things: AI, edge, and ecosystem. So AI, no surprise, right? But here's what was I found refreshing was, while AI was kind of the theme of the day, you know, Dell did a fantastic job of kind of digging in deeper and going beyond just the hype of Gen AI, right? They talked about the bigger AI picture. They talked about the AI ecosystem, how they're working with the ecosystem to enable it. And they actually brought customers and partners on stage. It was such a prominent part of the summit to have partners and customers talking about their journeys through deploying AI and obviously with Dell as the enabling platform. So that killed two with one, right? Ecosystem and AI. Third was edge. And, Dell has always had an interesting play in edge. They've always been strong in edge. They've kind of taken this horizontal approach to we'll provide platforms almost like an OEM and let others build on top of. But they've really codified their edge strategy. It feels like they call it native edge. And they spent a lot of time talking about how they're standing up, ecosystem partners within specific verticals in the way they're working together to deliver, call it tailored solutions, kind of, let's call it everything but that last mile for these verticals. Really, I like the story they're telling. Obviously stories are different than practice. I'm not saying they won't implement, but I really like the way they're approaching it in the strategy. I haven't talked to a lot of partners out in the market that are doing this yet, but it's more because it's not my swim lane, not because they haven't executed, but the way they're approaching, retail, manufacturing, these different verticals, and the way they're standing up key players, and they're really leaving it to the ecosystem to add the value I thought was a fantastic story. So I did that in 2 minutes. That's a record
great.
for me.
Good stuff. I was there for 8 hours. Wasn't unfortunately able to attend the whole thing. I did miss a lot of the NDA stuff, which is good because I can't talk about this anyways. But I met with senior leadership. I met with Michael Dell, Jeff Clark. I also met with Lisa Sue, who was a surprise guest.
Yeah.
I don't think we're allowed to say why she was there, but had a good conversation with her and Dell's new chief AI officer, Jeff Boudreau, who he has the X on the back to make stuff happen at Dell and make sure they get their unfair advantage on business and they're making the right investments and have the right strategy.
Yeah.
The big thing that I want to make sure I understand here about Dell is I want to understand their entire AI stack. Who plugs in? How do they plug in? I think IBM has done a good job on this. I think Cloudera has done a good job on this. I think that VMware has done an okay job at this. They didn't have a data layer, which was weird for on-prem data. IBM and Red Hat are building their own data layer and partnering, but it was good to see. So hey, let's move to this last one. This has got to be a Paul Smith Goodson special. AWS AI Party Rock. What is what's happening here, Paul?
Yeah, this is just kind of a little fun thing. AWS has come out with a little gimmick that you can use to make your own chatbot or your own little Gen AI thing. You can it's simple. You just put in your name, sign up for it, tell it what you want the chatbot to do. It'll create it for you. You can learn about prompts and prompt engineering and various things. It's at partyrock.aws, and you'll have your own little Gen AI that you can share. I tried to do it. I built one, and I'm too much of a geek, and it didn't know what I was talking about.
Wait a second. Is this like ChatGPT agents?
Yeah, you can. You can just build your own little app. Yeah,
I got you. Okay. Well, that's cool.
You got a
I
couple.
might went in kick the tires on that.
Yeah. Fill in a couple of blanks, and you're in business, unless you're a really geek like me and doesn't know what you're talking about.
I love it.
So
Paul,
anyway,
thanks for bringing that to our attention. It smells very much like OpenAI's agents, which, by the way, was the most exciting thing that was announced last week that I might mess around this weekend. But thanks for bringing the other one to our attention, and maybe we'll check it out before we go to AWS reInvent.
Yeah.
So, folks, I want to thank you all for checking in for episode 13. Please be careful out there. It's Friday and our episode 13 here. So y'all be careful out there. Give us feedback. Give me all the positive feedback and Paul and Matt all the criticizing.
No,
you know
Will
where to
gets
find us on
Will
social
gets the
media.
criticism.
He totally does. I had totally forgot that Will was not here, so, but don't tell anybody that. Anyways, thanks y'all checking in. Appreciate you. Hit that subscribe